This is section 10.4, and this is the last of our conics. We've done the parabola and the ellipse, and now we'll finish with the hyperbola. Hyperbola is the collection of all points in a plane that the difference of whose distance is from two fixed points, the foci, is constant. It has two pieces called the branches. So remember that with the ellipse, it was the collection of points whose sum of the distance from the foci was constant. This is the difference, so we'll have a subtraction in our equation. So there's two axes, but basically we worry about the transverse one. The transverse axis contains the foci and the vertices. The conjugate is a perpendicular to this transverse, and the two curves are called the branches. So let's look here. Here's the branches. The blue part is actually, this is the hyperbola. And then this is the axis, this is the transverse axis, and you'll know it because that's where the vertices are, or the foci. Both of those end up there. The conjugate axis is the one that's perpendicular to that. These two red dotted lines are the asymptotes, and those will be important as well. So let's kind of look at the main things, and these are on your handout if you've printed out the conics handouts. Both of these are on there. So if your transverse axis is on the x, so if your vertices and your foci lie on the x-axis, it's x squared over a squared minus y squared over b squared equals 1. Your asymptotes in this one are y equals plus or minus b over a. Remember, here's the equation where you can get your a and your b. Now, if it transverse axis is y, then the x and the y switch places. Remember, with the ellipse, the a and the b change places, but in the hyperbola, the x and y change. So if the transverse is the y, then the y squared goes first, and a and b are going to be the same. They're going to be here and here. And so here's where the y-axis is the transverse. Both the vertices and the foci are on there. And there's your asymptotes. And the asymptotes for these are a over bx. So that flips. Up here with the x-axis, it's b over a, and here it's a over b. So you'll just remember that, or refer to your sheet. So if you were asked to find the equation and graph a hyperbola with center 0, 0, focus 3, 0, and vertex 1, 0. Well, first of all, we know that the transverse axis is the x because the focus and the vertex, those are on the x-axis. So our a value is 1, that's your vertex. The focus gives you the c value, so c is 3. You find the b using that formula that you're given, b squared equals c squared minus a squared. You come up with b is the square root of 8, and b squared is 8. So the equation would be x squared over 1 minus y squared over 8 equals 1. Oops. If you were going to graph it, you could plot the 1 and the negative 1 on the x-axis. You could plot your y equals b over ax. That'd be y equals 2.8x and negative 2.8x. So you get these two dotted lines. That kind of helps you with the shape of your branches, because the branch will come in and touch at that vertex, but we don't know whether it goes like this or way up here. But if you have those asymptotes there, you can follow the shape. Okay. In this one, the vertices are 0, 6 and 0, negative 6, and asymptotes are y equals 2x. So we know the transverse is the y because there's your vertices. And we know the 0, 0 is the center. Y equals a over bx. Well, what do we know? We know that a is 6, and we don't know b. So if we know that this is the formula for the asymptote, and we're given that y equals 2x, then this 2 and this a over b have to be equal. And we know that a is 6. So 6 over b equals 2. Multiply your b over this way, divide by your 2, you get 3 is b. So once we have b and a, we can write the equation of the line. The y squared goes first because we know the transverse axis is the y. So y squared over 36, where did that come from? We squared the a value, minus x squared over 9. B was 3. All right. If we graphed it, I didn't graph the whole thing, but it is important to graph the y equals 2x. And then here is a 6, here is a negative 6, so your branches are going to go like that. Okay. All right, on this one, you're given the equation and you're trying to analyze, come up with some stuff. So x squared over 25 minus y squared over 9 equals 1. I know my a value is 5, my b value is 9. That would let me find the foci by using this b squared equals c squared minus a squared. Plug in what you know, you end up with c is the square root of 34. So if we're filling in, the center is at 0, 0, because you do not have an x minus something or a y minus something. The transverse axis is x, because the x is above its first here, so we know that that's the transverse axis. Vertices are at 5 and negative 5, that's there. And the foci would be square root of 34, 0, and negative square root of 34 and 0. And I think that, and we could figure out the asymptotes because it would be plus or minus b over a, and you would get these. So it's, I think that'll get you enough to get going on our problems. Let's go look at the problem set. All right, in number 1, we've just got some language in the first 3. Blank is a collection of points in the plane, the distance of whose distances from 2 fixed points is constant. Well, it's what we're studying in this section. It is the hyperbola. For a hyperbola, the foci lie on a line called the transverse axis. Use this to complete the equation below. So we're looking over here. Let me see if I can make that a little bigger for us right this moment. So this is the transverse axis. It is parallel to the y. So we know y squared is going to be on the top of the left, the first one. But what we should notice is we're not on the axis. We're over here. So the center is not at 0, 0. So that's going to be y minus k. K is the y part of the center, squared over a squared, minus x minus h squared over b squared. And that would be right here. Okay. All right. In a hyperbola, if a is 3 and c is 5, then b equals, well, you have your equation that you use, and we just plug in the parts we know, and that's straight algebra. You come up with b is 4. Number 5, for the hyperbola x squared over 9 minus y squared over 16 equals 1, they want to know the value of a, b, and which is the transverse axis. Well, the transverse axis is the x, it's first, and so a is 3, b is 4, and so you've got that right there. For y squared over 16 minus x squared over 81, wants to know the asymptotes. Well, your a value is 4, right here, square root of this. B value is 9, so it's plus or minus a over b, b plus or minus 4 over 9x, and you've got that right there. Number 7, find an equation for the hyperbola described below. Let me get rid of that little thing right there. All right, so the center's at 0, 0, and the focus is at 0, negative 8. The vertex is at 0, 3. So what that tells me is that a is 3 and c is negative 8. Here is our equation. We can come up with what b squared is. We know that a squared will be 9. So we come up with b squared is 55. So our equation would be y squared over 9 minus x squared over 55 equals 1. And so we are looking for, we're on the y-axis and we should be up 3. And so you'll look at this, it'll be bigger on your computer screen. But you can tell this is at 3, this is something bigger, and these two are on the x-axis. So it was one of these, but this one should be it. Number 8, we're going to graph that by hand. So I guess it's giving that, but we're supposed to try it. So foci at 0, negative 26, and 0, 26, and a vertex at 24. So we know that A is 24 and C is 26. Use your formula to come up with what B squared is. So if A is 24, that means 576 is going under the y squared, and 100 is going under the x squared. Again, we're on the y-axis, and we should be up 24. I think that one's saying maybe 31 or something. So you'll be able to tell that it would be that one. Number 9, find the center, transverse axis, vertices, foci, and asymptotes, and graph. So we did one of these when we talked about the notes. So here's our general equation. Center is at 0, 0 because we don't have an x minus or a y minus up here. X squared is first, so the transverse is on the x-axis. The vertices are at 7, 0 and negative 7, 0. How do we find the foci? We need to know what the C value is. So we plug in what we do have. We have an A, and we have, we don't have the C. So we plugged in the B and the A, and we solved for C, and we got square root of 74. So that would go there. The asymptotes are plus or minus B over A, so that would be 5 over 7. And I'm not sure, oh, you're putting them here. So the first one, the positive y equals 5/7 x, and y equals negative 5/7 x. And so it's either this one or this one, and we are looking for 7 and negative 7. So I believe it'll be easy to tell that it's over there. Last one, we're doing kind of the same thing. What we do have to remember, you're always wanting to be equal to 1. So we need to divide everything in this equation by 25 to make that 1. When we do, we end up with y squared over 25 minus x squared over 1 equals 1. So A is 5, B is 1. Y is the first one, so the transverse axis is y-axis. We're still at center of 0, 0. Our vertices are going to be at 0 and plus or minus 5. Foci, we need to find that out, so we use our equation, plug in the 1 and the 25 that we have. We end up with plus or minus square root of 26. The plus or minus a over bx, so that's going to be 5 over 1. So right here we can put in plus or minus 5x because we don't need to put that 1. And we're going to be right here. You'll be able to see that when you make it bigger, but you are on the y-axis. That's where your vertices are going to be. And you can't see it, but it's going up to 5. And the other one, I don't know, hopefully you will be able to tell that it's not this one. So I think that will get you going on 10.4.